A side note, at the end of class yesterday, I was talking about, sorry, end of class, Tuesday, was talking about overly high interest rates and what our internal rate of return measured. And I mentioned that there is an idea of an interest rate that's just outrageous. And in recent history, in 1985, the Canadian Criminal Code was appended to create a interest rate that was defined to be criminally high. I always looked at this and said, that's a weird definition, but I get it. This was amended in January of 2025, so this year, saying that an interest rate of 35% was considered criminally high. 35%. In the United States, we have state level usury laws. Usury was the original definition of a crime of lending at too high of a rate. Depending on where you practice, that could matter to you, both the US and Canada and abroad. Usury is an unusual crime in general. Predatory lending practices in the United States have been governed by different bodies at different points in time. People go back and forth on this. The Consumer Credit Protection Board was designed in the last 20 years to try and deal with this in America. It's not working very well. We're still working on that. Let's look at cash flows and interest rates in a slightly different fashion. If I have two different cash flows, again, I'm assuming they're not risky. I'd have to take risk into account. I'll pick a time, preferred interest rate, I evaluate that, and I can construct the present value and compare that. So if I think about the present value, like this, for each cash flow, I brought those back to today. I can think of that as a polynomial in I, or a function, sorry, a polynomial in V or a function of I. The examples we did on Tuesday, the present value of the first one was -1, and then it was 2.3v and minus 1.33v squared. If I turn that into I, -1, 2.3 over 1 plus I, minus 1.33 over 1 plus I quantity squared. I can think of this as a function of I, where I is between -1 and 1, because it's possible we're losing money. We did show some of our examples had an internal rate of return that was negative. Shouldn't rule that out. But there were several different examples we did. I had the second one had that final payment at 1.32. And then the third one I did had that final payment be 1.2825. Now, if I graph these as functions of I, or as functions of v, depending on which way we want to graph them, we'll get some interesting looking pictures. Wrong button. Minus 1.33 divided by 1 plus x quantity squared. So here are these three. The only difference is way out here on the end with what this number is. That's our first one. There's supposed to be, there we go. It's supposed to be three curves. We're going to have to zoom in quite a bit here to see a difference. So zoom in. I'm not getting a very big clearance. Let's change the window. We'll scoot it over this way some. There's my first one. Does it make sense that that had no x-intercepts? Go back to Tuesday. Look at what we got for the first one. There were no real roots. The second one we had 2. The third one we had 2, but the one of them was negative. That's our negative 0.05 right there, and the 0.35 right there. Okay, that worked. There was a fourth one given in the text in example 5.2, and here on page 255, we see all of these same graphs that we created. If I do this in terms of V, I'm going to get a different picture, but the same comparison in the way the graphs look occurs. Somewhere in here, I get to choose what's, quote, best. Let's figure out what that is. But there's a way to compute that present value ranking the interest alternatives in this fashion. Definition 5.2, the net present value method ranks possible investment alternatives by present value of all net amounts received. An interest rate is then chosen and present value is calculated. That interest rate here is usually called the cost of capital or interest preference rate. If the net present value is positive, then my investment will be profitable. If my net present value is negative, then it won't. But what we see in our graph is that there is a range of interest rates over which my investment will be profitable. So if I go back and I look at that graph again, that highest picture shows me that with any interest rate between negative 0.5 and 0.35, minus 5% to 35%, I'll make money. And in that first one, no matter what interest rate was selected, I won't make money. Net present value is negative for all investment ranges. Don't do that one, you're going to lose money, no matter how you attempt to rearrange the rate. So that's actually the utility of this curve, is for me to say, oh, here's the range of interest rates where I can make money out of this. But I've got to figure out how to do the rate of return based on this. And there are two primary methods for this based on the weighting systems. I want to adapt my internal rate of return calculation to adjust either by money or by time. The first one is called the dollar-weighted rate of return. And we're going to adjust the IRR calculation using simple interest. Now, this requires me to keep a balance at each point in time. So this is going to look more transactional as a calculation. We're going to have to run through what's happening at different points in time throughout the year. The value equation is built at the end of the year. I need fund balance at the start of the year, the amounts and times of all the cash flows, and then I need the balance at the end of the year. And then the value equation built at the end of the year takes the starting balance and all deposits with simple interest to the year end, and subtract all withdrawals. Again, with simple interest 2 years end. And that should be equal to the ending balance. That's our equation of value here. And then I'm going to solve for the interest rate. So I can work out my interest rate. I'm just using simple interest instead of compound interest. So this is just like the internal rate of return. And if the interest rate isn't huge, simple interest and compound interest over the course of a year work out almost equally. Here's an example. I have a fund with a starting balance of $1 million. On 1/1, let's use 2024. At the end of February, add $200,000. Woo, we made money. Same thing at the end of August. And then at the end of October, we're going to withdraw some money. Now, you'll notice I have not talked about what interest rate is being charged or used here because that's the thing we want to find. The question is, what is our balance at the end of the year? So on January 1st of 2025, our balance is $1,100,000. What is the interest rate that I earned in this investment fund over the course of the year? Now, this makes more sense. I gave you money, I took money out, I put money in. Here's the balance at the end of the year. Did I earn anything? Now, this is exactly what my 401k gives me every year. They tell me all the deposits I've made, all the withdrawals I've made, and they tell me what they earned. Now, they're a diversified portfolio. They've got stocks and bonds and real estate and all sorts of other transactions going on. And I don't get to see all the nitty gritty all the time, unless I really, really want to spend my entire day digging through their files. I'm going to throw off 5 zeros for the moment because I'm just not going to carry around 5 zeros. So I think of my equation. My starting balance was, drop 5 zeros, 10, and it earned some amount of simple interest for the entire year. I then deposited, drop 5 zeros, 2, and it earned some amount of interest, but it didn't go for the whole year. How long was that money in the bank? This money right here. It went in at the end of February. So how long was it in? Because I'm looking forward to the end of the year. It wasn't in for 2 months. It was in for all but 2 months. So it was in for 10/12 of a year. Similarly, with the payment that went in at the end of August, that's another $200,000 deposit. September, October, November, December, it was only in for 4 months. The end of October, I pull out $500,000. So minus 5, 1 plus I to the 2/12, November and December. And that should be equal to, drop 5 zeros, 11. $1,100,000. But now look, I've got to multiply this out. I've got 10 plus 10i plus 2 plus, wait a minute, that's 5 over 6 times 10, so that's 5 over 3i plus 2 plus, that's 1/3, so it'll be 2/3 I minus 5 minus 5/6 I equals 11. This is a linear equation. There's no complicated nothing here. Solve for I. Ten plus 2 minus 5 is 9 plus, I'm going to need a common denominator 6. So I have 60 plus 10 plus 4 minus 5 is 74 minus 5 is 69 over 6. I equals 11. 69 over 6i equals 2. What's my interest rate? Pretty big. I think you got a bigger number than I did. What'd you do to get from here to here? Okay.
Base 9 instead of 2.
Yeah, that would make a very much substantial difference.
0.1739.
Yeah. Now, that means that I earned on average 17% across this year, 17.4%. Let me look back at this line though here. This line right here with the 69 over 6i and the 2. What's that 2 represent? Hang on. I had a million when I started. That was our 10. I added 4. I subtracted 1. Subtracted 5. That's a net loss of $100,000 just in cash moving back and forth. So that 2 is the interest I earned over the course of the year. $200,000 worth of interest had to be earned at some point throughout this year. Not uniformly because the balances are going up and down, but the net amount of interest. And 69 divided by 6. What's 69 over 6? 11.5. That's my average balance over the year. Weighted by the number of months, the amount is in there. You've done weighted balances before. That's all that is. So I'm earning a net of 200,000 in interest off of the 1,150,000 that is averaged in my account the whole year. Do you see how the time is what's in here in simple interest, but it's really the amount of dollars in the bank at different points in time that give me this setup. This, by the way, is true all the time. There is a formula in the textbook for this. And I absolutely hate the way this formula is written. I want to show it to you so you can understand why I hate it. Definition 5.3, given A equals start of year balance. By the way, the start of the year doesn't have to be January 1st. It could be, as is most fiscal years, July 1st. It could be, as is the federal fiscal year, October 1st. The state of Pennsylvania's fiscal year starts October 1st. Start of year balance. 0 less than T1 less than T2 less than Tn less than 1. A net deposit of CK at time TK. Notice I'm going to use C being positive as in and C being negative as out. That's why our withdrawal was $500,000 was negative. And B is my end of year balance. Then net interest earned that's our 2 in the previous example. And the dollar-weighted rate of return, I'm going to abbreviate that from here on out as ROR, rate of return. Is interest divided A plus the sum CK 1 minus TK, which is effectively the calculation we did. I just don't want to recite this formula. I would rather remember, hey, build the equation of value at the end of the year. This formula drives me crazy because I have to remember what all the different pieces are. Build me a ledger using simple interest and give me the value at the end of the year. Questions? How different is this calculation if I do compound interest? All right. Hang on a second. Since I'm going for less than 1 year, or at most 1 year, this is actually an easy calculation to write at the beginning, right? There's my full year on the first balance. And then I stuck in 2, but it was there for 10 months. So instead of doing 1 plus IT, I do 1 plus I to the T. Same thing with the deposit in August, only that one's only there for 4 months. And the subtraction withdrawal in October is only there for 2 months. This is a less than ideal equation to solve because of all the exponents. But again, I have technology, I can do this. I go into my equation solver, I'm going to move the 11 to the other side because the equation solver requires me to use 0. Math solver. And let's type in the equation. 10, 1 plus x plus 2, parentheses, 1 plus x raised to the 5 over 6. I need to make sure I put those in parentheses because of the way this version doesn't actually give me the exponent on my calculator. If it does on yours, that's a software update that I don't have. Plus 2, parentheses, 1 plus x raised to the 1/3 minus 5, parentheses, 1 plus x raised to the 1/6 minus 11. Had to move it to the other side because it says equals 0 over there. And now I give it a guess and I just say go. Alpha solve. Think, 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 think. This is the same answer as the one you gave me, Adam, to 5 decimal places. It doesn't become different until here. So I can use 0.1739 or 174 and be accurate whether I did simple interest or compound interest. The more separated and discrete our transactions are, the more we must do this as a finite sum. If I have lots of little transactions that kind of look uniformly distributed throughout the year, then I can approximate this. But that uniform assumption will result in a very different looking final calculation. Because it kind of says, smear everything out over the whole year. And then our formula changes. Pen, here it is. I get this. That's a lot simpler of a formula, isn't it? Because all it did is assumed all of those transactions back and forth. Capital C is the sum of all the CKs. And then I use just the weight as 1/2. Half of them will happen before the beginning of the year, half of them before the middle of the year, half afterwards. So just put everything at 1/2. Statistically, this is assuming a uniform distribution. But uniform distributions are very, very uncommon in the real world. You would have to be literally putting the same amount of money into the bank every day across the entire year. I don't get paid daily. It's not going to work that way. If we did this for us, for the example we just used, I'd get 0.21, a very different answer. Our transactions are too disjointed to use this approximation. Questions? If this is dollar weighting, there's got to be another weighting, and that's time weighting. Time-weighted rate of return. We're going to compound the returns over successive parts of the year, but the length of each part is irrelevant. Now that sounds a lot weirder because the time, you would think saying time in the name, I should take the time into account. Well, the weight is actually saying I want to put the weight equally across all the time periods, as opposed to looking at each one separately and differently. But I need more information about the balances before and after each deposit. And that changes the amount of information I need. But this actually, I think, works a little better based on the idea of our interest rate changing over time. An example. Consider a known set of rates. Period 1, I earned 3%. In period 2, I earned 5%. In period 3, I lost money, negative 1%. And in period 4, I made 1%. Rates per period. So I throw my money into this account and this happens. How much is $100 worth at the end of this entire time? What's going to happen to my money? Well, $100 goes in the very beginning. At the end of period 1, I've earned 3%. What about the end of period 2? Oh, I made a copy error. I lost 2%, not 1%. What's at the end of period 2? What's my balance? But that's at the start of period 2, right? Because that's how much I had at the end of period 1, and I earned 5% during period 2. So I start with $103, 100 times 1.03, and then I earn 5%. At the end of period 3, I start with whatever this money is, right? That's the end of period 2 money is this, but I lost money during period 3. So if I lost money during period 3, I now have to multiply by 0.98. At the end of period 4, well, I made 1% during period 4. What is this number right here? So my net rate of return is 7.05%. A question for you. At any point in this example, did I say that the periods were the same length? My rate doesn't care how long the periods are if I know the interest rate during each period. But since my goal is to find the interest rate, how would I find the interest rate earned during period one? I'd take the amount at the end and divide by the amount at the beginning. That's the interest rate. But I also had a transaction maybe in there. In this case, I didn't. I just put the $100 in and let it go. But if I have transactions, I can adjust for that as well. But that means I need to know the balance before and after each deposit is made. And if I divide, I get the rate per period, and then I just multiply all those rates together. Because look at what happens if I multiply 1.03 times 1.05 times 0.98 times 1.01, I get exactly the interest rate we wanted. Well, 1 plus, right? That's my equivalent effective annual interest rate, 1 plus J. But the time spent doesn't matter. I'm going to need to know how much interest or growth occurred in each individual period. And then I'll be able to work this out. So I need some more information on my balance again. I'm going to use the same letters. If A equals start of year balance, a series of times 0 less than T1 less than T2 up to Tn. And again, a deposit of CK at time TK. Positive is in, negative is out. And I have an end of year balance of B. And here's the extra piece of information I need. FK is the balance in the fund just before time TK. What does that piece of information give me? Look at the very first period. The first period is going to go from time 0 to time T1. F1 is the balance just before the deposit of T1. Well, that's the interest A earned. So that's like the 1.03 back in our example. That's the interest earned during the first period. I take the amount at the end of the first period before I make that deposit and divide by the amount that went in. That's the rate during period one. And then I take the amount at the end of the second period and divide by the amount at the beginning of that period. But that period is F1 plus C1 because I put in the first deposit. And then I do the end just before the third deposit, and that's a plus sign. What went in? And I keep going. Fn over Fn minus 1 plus Cn minus 1. And then the last one is the ending balance over Fn plus Cn. Most of the time, that last number is a 1. Not always, because I should earn some interest at the end. Oh, if I actually want the rate, I should take this whole thing and subtract 1. And that's my time-weighted rate of return. I just multiply the individual weights across. Again, I need an example, or this is just me flapping my face. Two deposits and two withdrawals. Here's my balance sheet. January 1st, 2024, there is a $1 million balance. On February 28th, we add $200,000. Sound familiar? Now that means on March 1st, my balance is 1.2 million. On August 31st, I put in another $200,000. Oh, wait a second, that's wrong. This is not 1,200,000, this is 240,000. On 8/31, I put in another 200,000. On September 1st, the balance is 1.6 million. So I'm going to write that balance next to each balance. It is October 31st. I withdraw money. On November 1st, my balance is 108. On December 31st, I withdraw another $200,000. And so on January 1st, 2025, my balance is 900,000. Okay. I need to go through and identify each of these dollar amounts as one of the letters in my definition usable up here. So I need to know A and B and C, 1, 2, 3, and 4, and F, 1, 2, 3, and 4. Because I have 4 different transactions. I'm gonna have C's and F's in here. Okay, let's start at the top. What is this number? What letter does it get? The 200,000 is careful. What does the letter F1 mean? Balance before. That means that is C1. That's the cash flow at time 1. This is C1. I don't know F1, but I can find F1 from here. Because this balance of 1,240,000 would tell me that that's what happened right after I added 200,000. So F1 is 1,240,000 minus the 200,000 that we put in, or 104 1,040,000. Hey, wait a minute. I now know the interest I earned during the first period, don't I? What's this 200,000? And that means from here I can get F2. What's F2?
$1.6 million, almost, the 200,000.
Exactly, minus the 200,000. 1.6 minus the 200K is 1,400,000. During period 2, I had another growth. What is this? That's C3. So this helps me get F3. What was the balance in the fund right before I took out the $500,000?
$580,000.
Because that's a withdrawal, it's negative, means the balance was larger before I started. What happens here with this 200,000? What is that number? Yep. And that means that F4 can be found from here. What's F4?
$1,100,000.
And this number itself is
B.
our ending balance B. Okay. My formula says, take the amount at the end of period one. The amount at the end of period one is F1. Divided by the starting balance A. Then take the amount at the start of the second period, goes on the bottom. And the amount at the end of the second period goes on the top, F2. F2 is 1,400,000. What goes on the bottom? You can't see. What goes on the bottom of that fraction? The amount that was there at the start of the second period, F1 plus C1. And I keep going. The next one is F3 on top, which we worked out as 1,580,000 over F2 plus C2, which was the amount after I put that deposit in. That's this new balance, 1,600,000. Then I get F4 on top. And on the bottom, I get F3 plus C3. But F4 is 900,000. And F3 plus C3, oop, wait a minute, that's wrong. F4 is not 900,000, F4 is 1,100,000. I got to read the right number. 108. Because that was where we did a withdrawal. Now, here's what I meant by the last one is 1. Because the very last fraction should be the ending balance over F4 plus C4. But we didn't leave the money in the bank for very long. There's only one day here. Our ending balance is 900,000, but F4 plus C4 is also 900,000. By the way, I'm going to end up subtracting 1 from this number when I'm done. If I did not have a transaction on the very last day of the balance period, this fraction would not be 1. This fraction would be different than 1. But there were no transactions between the ending balance and the end of year, and no time, so there was no interest earned there. If this last deposit transaction behavior wasn't December 31st, I'd have a whole different behavior. What do you get? Give me a number. Now, here's the part that makes me twitch. This is the time-weighted rate of return. But what it is disregarding is the time frame. It's really allowing the deposits to go in whenever, and just whenever the deposit goes in, that's the time period we're going to look at. But by knowing the balance before it goes in, or the balance immediately after, and taking that into account, I can calculate that regardless of the length of time that has passed. I think we should be calling this time unweighted, but I don't get to make the names. We are, in a very real sense, saying the time in which the period went doesn't matter. The length of time of each period was dramatically different. My first period was 2 months, but my second period was 6. I don't care. The rate of return here and the rate of return here are different, but I'm smoothing that out to average it over the whole year. Joe, you're looking at this in an unpleasant way. What's up?
No, I'm not stuck with calculation.
Ah. When I did the calculation, I chopped off 4 zeros from all of these. So if you look at what I actually wrote on my calculator, I have 158 over 160 and 110 over 108. And if I go further back, I have 140 over 124 and 104 over 100. Because I know that the extra zeros are just going to cancel all the way through. This is rarely used on periods longer than a year. Dollar-weighted returns have more applications for longer terms than time-weighted ones. But I am not an accountant, nor do I pretend to be one. So I'm sure someone somewhere is going to tell me that there's a reason to use one over the other based on particular accounting practices. Most of the time, that's based on law. There's some sort of regulation or requirement that says you have to use this method or you have to use this method for your rate of return calculation. I'm not practicing in the field. I don't know what that regulatory environment is. This again goes back to the idea of the usury rates that we talked about at the beginning of the class. Your regulatory environment matters a lot. In other words, the government's out to us again and make us do the work the way they want to see it for whichever type of environment we're working in. Questions? Two things. That's the entirety of rates of return or internal rates of return for me. That's the end of this chapter. You just gave me a homework. It means a week from now, you give me another one. But that's 2 chapters worth. I don't want to string you along longer for another exam. So we're going to have an exam week from Tuesday. I'm writing it this weekend. So it's going to look like the other 2 exams, mostly like homework problems or similar to homework problems. 5 or 6 of them, write yourself another formula sheet because we got a lot of formulas on this one. Put good notes on them. You'll again get the ACTEC formula sheets that we got for exams 1 and 2. Questions? I will see you all on Tuesday. Have a wonderful weekend. Happy Halloween tomorrow, because I won't see you then.